Alright, in this video I'm going to show you how you can build and install opencv with NVIDIA Cuda support. We are going to build opencv-DNN with cuDNN as well. Alright, so we are on a fresh Ubuntu 20.04 installation here. I didn't manually install the graphic driver, NVIDIA driver here. It automatically installed it when I check the install third-party software in the installation period. If I check NVIDIA settings here, you can see it's running NVIDIA driver already. This is not the open source driver, this is the proprietary driver. You have to make sure that, because it's not going to work with open source driver. Alright, let's jump to Cuda installation. You will find a link to this documentation in the video description. First, I'm going to download Cuda, and you can just click on download the NVIDIA Cuda toolkit, and here you can go to Cuda downloads, select Linux 64 architecture. Then I'm going to select Ubuntu because I'm running Ubuntu. Version is 20.04, and I'm just going to get this deb package right here. So to download deb package, all you have to do is run this command. Make sure you have wget installed with Ubuntu. I think it comes with Ubuntu. I can just check that wget version. Yep, it's already there. So just run this command and it will download the deb package. Alright, I'm just going to go back because I already have it here inside NVIDIA. This is the Cuda deb package. Alright, now I'm just going to go back to the original documentation and let's check out pre-installation actions. So you need to have a Cuda capable GPU. I have a GTX 1060, so that's a Cuda capable GPU. That's not something I should worry about. And verify you have supported version of Linux. You can just check that out. I'm using latest, that's going to be fine. So I'm just going to continue to the next one. Verify the system has GCC installed. We can just quickly check that using GCC version. Okay, that's not installed. Now I'm just going to install that using this command. Alright, GCC installation is done. Just to verify, let's run GCC version now. Alright, right now we are using GCC 9.3.0. You may have to check GCC compatible version for your Cuda release. Otherwise, you may run into some issues when you are compiling your application. Alright, now GCC is done. Let's go to the next requirement or prerequisite. Verify the system has correct kernel headers and development packages installed. Scroll down to Ubuntu. So this is all you have to run to install kernel headers. You probably already have it if you're using 20.04. So I already have it, and let's continue. Now you should download Cuda, but we already have it, so I'm just going to jump to package manager installation, and I'm going to click on Ubuntu. Okay, now we are going to install the deb package. So let's navigate to the folder and right click, open terminal here, and let's do sudo dpkg-i and Cuda repo, hit tab to autocomplete and hit enter. Enter the password. Alright, that is done. Now it shows a warning, the public Cuda GPG does not appear to be installed, and we are going to install that next. So it shows basically the command that you need to run, and I'm just going to copy this paste it here and hit enter. Okay, that's done. So we installed the GPG key. Now let's jump to the next step, update apt repository cache, and I'm just going to copy this command and update. Okay, we just updated the package cache and we are going to install Cuda next. Okay, that's done. I believe that's the last step. Here we have, yes, so we are done with the Cuda installation. Now I'm just going to restart the PC, so be right back. Alright, I'm back. Now you want to make sure that you don't have any issues with the graphic driver you have installed previously after the Cuda installation. Otherwise you will have to resolve that first before continuing. Okay, now we don't need these two tabs. Let's continue with the cuDNN installation. Before you download cuDNN, you have to log into the NVIDIA developer program. So go ahead and do that first. If not registered, you can register using Gmail account. Once you have done that, you can just go to cuDNN homepage and click on cuDNN. Here I'm going to agree to the terms. Here you want to make sure that you're downloading the correct version for the Cuda installation you have on your system. To confirm that, you can get the Cuda version. Now if you run nvcc, that's not going to be available by default for some reason. You know, the bin is not in the path environment variable, but I'm just going to mention set the direct path to that binary, that is user local Cuda bin and vncc, and let's get the version here. Oops, I may have, sorry, it's nvcc version and we are running 11.3. okay, this is the version I want. Here I'm just going to get deb packages because I'm running Ubuntu. I'm going to download runtime library, developer library, as well as the code samples. If you don't want this, just ignore this one right here, but other two, download them. I already have them, so I'm not going to download them again. These are the 3 deb packages from that page, and we are just going to install all of them. So let's run sudo dpkg I. Let's pass the first deb package. Oops, let me undo that. F2 control all copy, then let's go back and paste it here. Okay, my caps lock was on. Let's run the next deb package, which is dev package. Control all copy and sudo dpkg-i, then paste the deb package. Now let's install the code samples as well. Same thing, but a different deb package. Alright, now we are done with cuDNN installation. It's just going to play some header files and libraries in the system. Alright, now I'm going to install Git because I want to clone opencv and opencv-contrib repositories. So let's do sudo apt install git. Once Git is installed, you can go to opencv GitHub repository and copy the URL, go back and just type git clone and paste the URL to clone the repository. Do the same for opencv contrib as well. I already have them, so I'm just going to open that. I have both of them in the same directory, and I'm going to create a new folder called build. Now to build the project, I'm going to need CMake, so let's install that as well. Sudo apt install CMake. I'm just going to install CMake GUI as well, it's easier to use. Okay, now fire up CMake GUI. First, I'm going to select the source directory to opencv directory. Open that. Next, we are going to select the build directory to the one we created, this one right here. Now hit configure and select the native compiler and Unix makefile. Alright, before anything, I'm going to select the path to extra modules. So search for extra, and for the opencv extra modules path, select the opencv contrib modules path. You have to go into modules and select. Okay, now let's search for Cuda. Enable opencv DNN _ Cuda as well as with Cuda flags. Now let's search for Python, because I'll be using opencv with Python. Here you need to set these paths. You need to set the executable. You can quickly search that using which python 3, if I can type that correctly, which. This will give you the path to python 3. Now you have this. Now to get the python 3 include dir path, I found a question in Stack Overflow. So run this in Python. Let's open up Python interpreter, python 3. Let's import this stuff and let's pretty print get paths, and here we have include path to include directory. Just copy this one and paste it for the flag. Now next up we have python 3 library. I just used find command to find that. Let me close this. I used find starting from root, and I include the name. It was lib python and something, so let's output all that to a file called out. Now let's use less out to read the file, and here you will find .so file. So we have multiple files, but this is the one I'm going to use, and copy the path here, paste it to the library. Again, it should be lib python, the python version you have, and .so file, because it's a library. Next up we have python 3 numpy include directories. First of all, you need to install pip, so let's do sudo apt install pip. After that, you can install numpy. Use pip to install numpy. Sudo pip install numpy. Once that's done, you can find the path to numpy include directory. Let's use find command again. Find, start from root, name of the file is numpy. Numpy. Again, I'm going to use the same file to write output. Let's out, and we have include directory. You don't need to copy this numpy directory as well, just copy up to include, this one right here, and paste the path. Now to set the package directory, you can use the same path you have used for numpy, but copy up to dist packages. Copy this, use a local lib python directory, then dist packages, copy up to this and paste it here, just like that. Okay, now I'm going to hit configure. Okay, we are done with the second level configuration. I'm just going to remove the search. We still have flags in red color, so we are not done. Next up, we are going to set arch bin. So let's search for arch. Here you can see we have all type of versions here, but you only need to include the version that you want the support for. Now I'll open up Wikipedia Cuda page, and here if you scroll down to this table and find the graphic card you have, I have a GTX 1060, and the architectures used in GTX 1060 is Pascal, and the arch bin version is 6.1. You can either set the arch bin version here manually to 6.1, or else what you can do is you can search for Cuda, and here you will find Cuda generation and select Pascal here, then hit configure again. You can choose either version to configure arch bin. You can hit configure. Now if you look at the arch bin again, you can see we have 6.0 and 6.1. I'm not sure why it's selecting 6.0. Yeah, I'm not sure about that, but if you only have 6.1 for GTX 1060, it is still going to work. Now you can hit generate. We no longer have flags in red color, so hit generate. Now the generation is done. Now we can continue to build the project. Let's close CMake, go to the build directory, open up a terminal window here, and let's run make to build the project. Now I'm going to add time just to check how long it's taking, and let's run make. I'm going to use 4 processors to build this project. You can check how many cores you have and add the number here, so we can divide the build process. Now I'm going to hit enter. This is going to take some time. On my machine it's taking almost 1 hour, so I'm going to let it build. Alright, we are finally done building opencv. It took 52 minutes on my PC. Now let's install opencv. To do that, I'm going to run sudo make install. The same way you can uninstall if you want to, sudo make uninstall. So we are done installing. Alright, now let's validate that we have opencv with Cuda support. For that I'm going to fire up Python 3. Let's import opencv, and I'm going to call cv2 Cuda get Cuda enabled device count and this should return 1 because I have one graphic card. And there you go, we have built and installed opencv with Cuda and cuDNN support. So that's it. Thanks for watching. Have a nice day.